Hi everyone, I wanted to share with you our recent web app that has to do with a recent publication that Mokbel and I published in Software X. It has to do with dimensional analysis. The software is called BuckinghamPy. It's a software written in Python, hence the play on the words here, PY, and it implements the Buckingham pi theorem for dimensional analysis. You can follow the link buckinghampy.tsat.net to get to the app, or get to it from the GitHub website. So if you go ahead and grab a new browser, you can type in buckinghampy.tsat.net and you will get to the software. Once you open up this software, it is going to start with a basic example, which is a pressure drop in a pipe. There's a lot of things going on over here, and I'll try to explain them as best I can. So first, you are loaded into a default session in which you can input your variable names, the dimensions of those variables. You can select whether you want the variable to show up only in one of the dimensionless numbers. Say you're interested in velocity, for example, and you don't want to see the velocity in all the dimensionless numbers, so you can select the non-repeating. You can also delete a variable and if you don't want it anymore, and you can undo it. Now, this button over here will run the program for you. So I'm going to go ahead and run this example for the pressure drop in the pipe. Once you click execute, it gives you this spinning wheel, and then it prints out all the dimensionless numbers for you, which is really great. You can go ahead and copy a link for this, and it will share it with someone else. You can save this session. It automatically downloads it as a JSON file. You can duplicate a session. So this would make a copy of that entire session. So I'm going to go ahead and delete it, remove it. And you can also create or reset everything in a session. So let's duplicate it again and reset. It will reset everything in this session so that you can start from scratch. Okay. Now, this button over here will allow you to load a session from your machine. So you can click on it and upload a JSON file. It will automatically load it into a new session. The undo button will allow you to undo a deletion. So for example, let's go back to this session, and let's say we deleted this variable over here. If you click undo, it will bring it back. You can only undo one time the most recent thing. And finally, over here you have this thing called models. That's a pretty powerful feature of this app. And it allows you to essentially experiment with different dimensionless, with different variables, different control variables that you're exploring a certain problem. You want to try it out with viscosity, without viscosity, for example, and these models will allow you to do that. You can also duplicate models, all right, and you can also add new models from scratch. Okay, you can remove a model. You cannot undo the removal of a model, however. Let's go ahead and do an example together. The example that I chose is by Professor Ken Cameron from MIT, which has to do with the dimensional analysis of designing a parachute for the Mars rover. Ken has a great YouTube video explaining how dimensional analysis works, and the video is linked over here. And the idea is you want to design a parachute for the Mars rover so that it reaches a certain terminal velocity, some terminal velocity, let's say 90 meters per second, when it is deployed on Mars, and you want to design the parachute over here on Earth. Now assume that all other parachute parameters except diameter have been determined, such as parachute material, the number of strings, etc. So that leaves us with the following variables that we are dealing with, and first one is terminal velocity, given here by the symbol V, and dimensions R over T. Then the fluid density, rho, so that's if you're testing on Earth, that will be the air density on Earth. If once you deploy on Mars, that will be Mars's atmospheric density. The canopy diameter for the parachute, the payload mass, m, and the gravity on Earth or on Mars. And finally, the fluid viscosity, I put question mark here over it. If testing is going to be done in water, for example, then viscosity is going to be an important parameter. If not, if testing is just going to be done in air here on Earth, so we can neglect this parameter. However, I included it here because it will allow us to explore how we're going to use models in our application. So let's go ahead and try this out. I'm going to go ahead to the app over here and create. Let's move this a little bit to the side. I'm going to create a new session over here. I'm going to call the session Mars rover parachute. Okay, and our initial model is going to be without viscosity. All right, so we're going to enter here the terminal velocity and simply type in L/T. Now you can add a new variable by clicking this plus symbol over here, or you can press tab on your keyboard and it automatically creates a new variable for you. I'm going to put in density. So this app accepts LaTeX symbols. So we're going to put rho with dimensions m/L cubed. Okay, again, press tab, put in canopy diameter, dimensions L, payload mass, lowercase m, has units of dimensions of capital M, and finally gravity G has dimensions of L/T squared. And because we are interested in determining the velocity, you might want to click non-repeating over here. You want to select non-repeating over here. So let's go ahead and run the software, and it gives you a bunch of dimensionless parameters. And if you select non-repeating over here, clearly it's going to select a subset of those where V shows up only in one of the parameters. In Ken's video, this is the quantity that was determined, V over square root of dg for the first dimensionless term, and the second one rho d cubed over m. And those are the dimensionless parameters done with the click of a button. Now let's say you want to try this out, but you want to add viscosity. What you can do is go ahead and just duplicate this model that you've selected here. So you go ahead and duplicate it. It creates a new model called without viscosity copy. Clearly you want to edit that, call it with viscosity. Okay, we're going to go ahead and add viscosity over here. Simply put \mu with dimensions m/L/T, and then if we click run, it gives us another set of dimensionless parameters. There's a lot of them over here, and this one is going to include the viscosity in the calculation. So it essentially added one additional dimensionless parameter. We hope that you will like this app. Please let us know if you end up using it. If you find bugs or you have feature requests, please email me or Mokbel. We really appreciate your time and any feedback you have. Thank you.